We're coming now to what is the last part of this tutorial, and that's the one where we are starting thinking about, okay, what's happening under the Triassic and essentially through that Carboniferous succession. So as I said in the previous video, the rocks are changing laterally, and that's something that you can see very well if you start looking at this stratigraphic column, is that things are not the same. So you've got a column that is for it's written here. I don't exactly know which area they refer to, but that's the Somerset, Caulfield, Mendips, and Clevedon Portishead area. And you know, and this is the Bristol, Caulfield, Broadfield Down, and west of the River Severn. So there's two geographic areas that have been identified, and over this area you can see quite dramatic changes in the type of rocks that are exposed, but also their thickness. Their thickness is can be very different at different time. Now, if we think about what sort of environment we were in, we're going to look essentially at the Carboniferous limestone series in our area. And when you look at the type of limestone, you can see that you've got a few of them are oolites. And that tells us that this environment was, unlike it is now, was probably a reef at the time. So during the Carboniferous, the Bristol area was a tropical reef with different types of rocks being exposed, being formed at different locations. And that's typical of reefs, is that reef laterally are not going to be, you're not going to have the same rock type being deposited in the same place. When you look at a reef, you've got the internal reef where you may have the oolitic limestone that form, then you will have the reef itself where you will have more bioclastic limestone, and then you can get on the talus where you will have again some different type of limestone that will be formed. So at the scale of a reef, within a few kilometers, you can have big variations in terms of the rock type that you're going to form, and that's what is represented here. So what we observe here is what we call lateral fascist variation, and you can see that there are units that are present on the left stratigraphic columns that don't exist on the right stratigraphic columns, and even within one stratigraphic column, you can see that there are things that are only present locally. So for example, you can see that in D2 the Brington oolite will be pretty much everywhere, but the Vallis limestone, that's what this triangle represents. In some places you will have the Vallis limestone at the bottom of D2, and in some other places it won't be there. So these units will appear just locally as a result of the change in paleogeography on the reef. So how are we going to represent these different units? So what I recommend you do, again, we're going to fill in the landscape from the youngest to the oldest. So we are done with the Triassic, we're getting into the Carboniferous succession, and the youngest we're going to have that is exposed along our line of section is D3. You can see D3 being exposed here, so it's that light blue here, and there's a bit of D3 on the other side of the syncline here that appears here. So we've got the contact between D3 and D2 is here. We can find it here on our line of section here and here. So we know it's there, and we've got a very good indication of the dip. It's 20 degrees here, and it's 65 degrees here. So this is something we can do. So I'm going to schematically draw, okay, we've got our syncline, and then the anticline, we've got a bit of topography. And what we have here, so that's north, that's south. We've got our Triassic here. And what we have here is the contact between D3 and D2 here, which is dipping at 20 degrees here, and is dipping here at 65 degrees. So what we have here is an asymmetric syncline here that you can see this way. Now D3, the thickness is fairly constant. You can see between the two units, you can calculate a sort of average. It's not going to be massively different. So you could represent that D3 on your line. So once you've calculated the thickness, you can represent the D3 bed here. Okay, and it's going to come here, and the contact is not going to come to the surface, it's going to intersect just underneath the unconformity. You can represent D4. We've got evidence that D4 is exposed here. So D4 pokes through the Triassic here, so you can represent D4 here. Again, you can take an average between these two, but you can calculate an average thickness, and then you can represent your D4 here, which is going to be on top. Should be the same thickness, and then come up here. Now we're getting into the D2, and what I recommend you do at that stage is think about representing the whole D2 unit as one package. So what we have here, we have, for example, on that side of the syncline here, D2 is made of, so we've got that green layer here, then we've got a dark blue, and then we've got the Brington oolite. So what you're going to have to figure out is what these units represent. So that's D2. The dark blue is D2. The green here is China stone, like it's put. It's a particular type of rock here, so it's the China stone. And then you get into D1b. So the contact between D2 and D1b is going to be here. So again, dip of 60 degrees here, so still fairly steep, and you're going to have a contact that is going to be like that, and it's going to go down. And you can see that in that case, this is made of, we've got that light blue D2, which is the Brington oolite. So you're going to have the Brington oolite here. You're going to have something in the middle, which is the D2, D2 without particular rock units. Then we've got the China stone. So you're going to have here, it's going to be D2, and here the China stone. Okay, so this is your boundary. This is your D2 unit. Then you get into the, and we're going to think about what happens when we get on the other side. Then we get here, and we've got D1b. We've got the dip, we've got the contact, so it's fairly easy to constrain the thickness. So you've got your D1b here, and then you've got D1a, and then, so D1b, D1a, and then we get into the C3, which is the upper old red sandstone. We don't know the thickness of the C3, but if you want, you can calculate it. You can calculate an average and do something in dashed line. So we don't really know what's happening here. We don't really know what's happening here in the syncline as well. I guess we probably have the units that get above D4, so we probably get into the lower cold measures and so on. But in the absence of more information, we are not going to represent anything. Now, in most of the practicals and most of the material that we've been talking about so far, we said you need to keep the thickness of the rock units, of the sedimentary units, constant unless stated otherwise. And that's going to be one of the situations where actually we may have to put lateral variation in thickness, because as you can see, the thickness, the units are changing laterally. We've got this lateral fascist variation. So for the D2, we're going to have to apply that in particular. So here the D2 is made of the China stone, D2 Brington oolite. When we get on the other side here, for example, the Brington oolite doesn't exist. No, the Brington oolites exist here, but then we've got the CDL and CO, the cheddar oolite, and what is CDL? CDL, the cheddar limestone that appear here. So these things will appear and make up the D2 units here. On the other side here, the Brington oolite is gone, and we go into different D2 units. So I think what we will have to do is represent this. So we're going to have the D1b as well, the D1a, and so on. But what we will have is that, for example, the Brington oolite is going to laterally disappear here. The China stone is going to disappear as well. So what you will have to find is to find some patterns for, let's say for the oolite, you could have the limestone square and put some dots in the middle. and then you will have the D2 unit itself that will be represented by a package that will appear on the other side. So here, for example, we're going to have D2 coming here and here, and different units that are going to progressively disappear within the D2 units. So on the other side, we can see, for example, we're going to end up with the dark blue D2, then we've got the light blue D2, then we've got the dark blue D2 again. The light blue is probably GCO, which is that Goblin Comb light. So this Goblin Comb light is going to appear here. Well, I didn't allow space, but it's going to appear here. But because it's there and it's not there, again, it's something that is going to disappear laterally. So light, you can have, again, these patterns that show that these units are not laterally continuous. Okay? So what you're going to do is have these individual units that disappear laterally. Make sure that they appear in succession as you expect them to be. But overall, you can see that the D2 succession has a thickness that is constrained by, so it's going to be, that's the minimum thickness, that's the maximum thickness. So again, it's not going to be a doubling of the thickness or anything like that. Okay, so once you've done that, you can see that you can progressively build your cross-section and finish it with the different units exposed here. The final result should be something that looks like that. So, did that keep recording? Well, we'll see. So it's like this is the model cross-section, and you will see in that case that